Okay, there's going to be an introductory video on disk, followed by another video or two on disk. Then there'll be an introductory video on washers, followed by another video or two on more in-depth stuff with washers. So just be aware of that. So here we're talking about disk method. Now, for the most part, you know to find the area underneath the curve. Basically, we're doing areas of all these rectangles together where how wide they are is our dx. How high they are is our function f of whatever. And we looked at beginning of chapter 4 doing Riemann sums and adding all these together and then taking our limit, which ends up being the integral from a to b of your function, and then dx once again is your width. Now we can go ahead and extend that into 3 dimensions and look at finding volumes of revolutions. Here's a solid that you get from revolving a certain shape, kind of like an L shape, around the axes. Or here's some other volumes of revolution. So how do we go about doing that? So a solid of revolution is basically where you take a shape like this, like a rectangle, and then you revolve it around this axis. Well, if you take that rectangle and revolve it around the axis in 3 dimensions, you basically get what looks like a disk. Well, when we were looking at doing area underneath the curve, we would just take and add all these rectangles together and then take the limit as the width of the rectangles goes to 0 or the number of rectangles goes to infinity. Well, we can do the same thing here. We can do the all these disks added together, and well, when we do that limit, it ends up going towards our integral. So to find the volume of your disk, it's really just your circle, which is pi r squared, times your thickness, the d or the w. Well, in the context of integrals, that thickness ends up being your dx. So when we're looking here, once again, that's review from your uh, area underneath the curve. So if we're looking at all these disks being added together, your W is your width of your rectangle, or of your disk, I mean. And remember, the area of a circle is pi r squared. So we put a pi in front of your integral, and then we really just have to do your radius, which often ends up being your function, and square it. Not always, but often ends up being your function. So for the most part, if you're dealing with a horizontal axis of revolution, you're going to be using this. Notice horizontal axis of revolution, you're dealing with x's. Vertical axis of revolution is pretty much the same thing, but you're dealing with y's. So let's take a look at this. We have our function, which is just our square root function, and we're looking at the volume of revolution that is formed by taking this function and revolving it around the x-axis. And we're only looking at going from our function out to x equals 4. Well, x equals 4 is a vertical line right over here. Now, for the most part, we could draw this. To be able to draw it to kind of give you a visual idea of what's going on, what I would do is I would go ahead and basically do the mirror image of this across my axis of revolution. This is my axis of revolution right here. This is what I'm revolving around. So I'm going to take this and reflect it down, take this and reflect it down, whoops, and it would go to here. I'm going to draw in my reflection down here, and I get this. Now, remember, I'm only going out to 4. So now I would draw in an ellipse right here. Man, my drawing is bad today. Wow, that's a bad ellipse. Sorry about that. But for the most part, this would be the shape that we're looking at. Now, if you go down here, here's a picture of this, where this right here is your axis of revolution. The origin would be right over here with your x-axis coming out this way, your y-axis going here. This was your square root function coming up right here. So that's the three-dimensional object. And I do have this object in class for those of you that come to class so you can see it in person. So for the most part, we need to go ahead and use this formula here. We need to have our pi, because remember, area of a circle or disk is pi r squared, so we do our pi. We're dealing with x because we have a horizontal axis of revolution. So then your two bounds right here need to be your x's. Well, it starts at 0, goes all the way over here to 4, so then your bounds and your integral are 0 to 4. Now, your function is, what we're looking at here is really your radius. Now, your radius goes from here to here. So it's really your function minus, which is on top, minus what's on the bottom of 0, which is just your function minus 0, so it's just your function because subtracting 0 doesn't change it. Well, we can simplify this a little bit. We can square your square root and we just get x. And now that's pretty easy to integrate. So we integrate and we evaluate and plug in our 4 minus what we get when we plug in 0, and we get, in this case, 8 pi. And some of you will do that at holiday times with your family. You'll eat pie, or you will have 8 pi.